we're asked to find the sense, magnitude, and direction of the following vector, vector f. And so let's go ahead and start with the magnitude real quick. So to find the magnitude, we need to find the x and y components. So we need to find the x component and the y component. So let's start with the y component. Well, the y component goes down 1, 2, 3, 4, 5, 6, 7, 8. So we'll call this f of y equals -8. Okay, equals -8. And our x component goes to the left, 1, 2, 3, 4, 5, 6. So we'll call this f of x, and that equals, since it's going to the left, -6. So equals -6. And if you think about it, these negatives tell us the sense. The sense is, of course, since it's going -6 in the x direction, it's to the left. And since it's going -8 in the y direction, it's going down. So if we have these numbers, we have our x and y components, then we have our sense. And this is important to recognize. And if it is too easy and too obvious, that's a good thing. It should make perfect sense because math. So anyway, back to our magnitude. To find it, we'll just do a squared plus b squared equals c squared. And we know a squared is, what, -6? So -6 squared. And then we'll say plus -8 squared. And then we'll set that equal to whatever c squared is, which we don't know. Well, -6 squared, -6 times -6 is positive 36, plus -8 squared is -8 times -8 is positive 64, equals c squared. Well, 36 plus 64 equals 100. So c squared equals 100, which means c equals 10, because the square root of 100 is just 10. Well, that's our vector force. That's our magnitude. That's what we were calculating. So equals our vector f. So equals 10, and in this case, centimeters. So that's what our distance is 10 centimeters. And of course, what's our direction? Well, to find our direction, we will have to calculate the angle. So our direction, and we can use sine, cosine, or tangent. I'm going to go ahead and use tangent because it was based on these first two numbers. So that's going to be equal to, well, we'll set question mark, equals the inverse tangent of the opposite is 6, and the adjacent is 8. So we just type this into our handy-dandy calculator. We say the inverse tangent of 6 over 8. And I could have used sine or cosine, don't forget, but I chose tangent just because it made sense to me. We get about 36.9 degrees. 36.9 degrees. And it's 36.9 degrees off of the y-axis, from the y-axis. And I could say that it's coming around this way, which would be, what, clockwise? I could say that's clockwise.
And in fact, it's probably more correct to say, so let's go ahead and write that out. 36.9 degrees clockwise from the negative y-axis. And if you think about it, this is saying the same thing as our sense, 36.9 degrees off the y-axis down and to the left.
So what does this mean? Well, we found an original vector and we didn't know what it was. We found out that it moves 10 centimeters of a direction 36.9 degrees away from the y-axis. And that's it. I mean, that's literally what it means. It means it moved this direction, this amount.